Hi everyone, welcome back. In this video, we're going to talk about the system design of the live video streaming. We're mostly going to focus on two main components, data ingestion and data delivery. We're going to look at them from different perspectives. We'll review the component design, we'll talk about the infrastructure and network. For the data ingestion, we're going to look step by step on how the data is transcoded in the real time. And for the data delivery, we're going to talk about the different aspects of delivery systems like CDN, ISP cache, edge cache, etc. With that, let's get to the video. We're going to start with overall system design and high-level representation of the system. As you can see on this diagram, it combines two components, the data ingestion component at the top and data delivery at the bottom. So it all starts at the top left corner, as you can see here, where we have a production site. Usually the video is recorded in the real time at the production site. It can be a soccer game or it can be your laptop that you are streaming data from. As you're recording this video, we need a way or a protocol to stream this video in the real time to a remote location. Usually it's a data center where the video would be transcoded later on. And for this, we're going to use RTMP protocol, which is TCP based and very reliable, because at this point, we want to make sure that whatever video is streamed, either it's a soccer game or your laptop, we want to maintain a high quality video and do not lose any packets during the transport. So we're going to use a reliable TCP-based video protocol to stream the video from the production side to the data center where we have our transcoding servers that transform videos into different formats. Now, how do we stream the video? Usually it would be likely 1-second fragments that the production side would be sending through the TCP protocol to our data centers. So every second, a small fragment of the video would be sent. As the video getting streamed and then received in the transcoding service, first thing we would store it in our distributed file system and then cache it, just so we have an original video in case the transcoding service fails, so it can recover that fragment and process it again. In my previous video on YouTube that you can watch here, I call it original storage. This is a place where we store our original fragments or videos just in case the transcoding service fails or something fails upstream the system, so we can always recover it and reprocess again. As the original 1-second segment of the video getting stored, transcoding service responsible for creating a table of the different formats that we want to transcode this original video to. You can think about it as 2D matrix, where on the one side we have different codecs for the video, and on the other side we have different resolutions of the video. Because for every resolution, we would want to have multiple encodings, so these video fragments can be played on different types of devices, whether it's a HD screen or it's a phone or it's something else. So for every single resolution and the codec, we create a job that is sent to the job scheduler. Job scheduler is responsible for getting that video segment and transform or transcode that video segment into the specific format and then store it in the file system. As you can see here, job scheduler would have multiple workers working behind the scene that would receive that message with the task on what has to be done with specific video. The worker would receive a message with the information about where the original video located and the task that has to be performed, what kind of resolution and codec this video has to be transcoded. Then it would get a original video from the cache and transcode the video, store it into the distributed file system, then cache it, and send a message about the job completion to a separate queue, as you can see over here, from the workers. This queue is responsible for decoupling the data ingestion system that receives the video, stores it, and transcodes it to multiple formats from the data delivery system, the system that's responsible for fan out of the video, delivering the video to different locations, and making sure that users can retrieve it with a very low latency. All right, at this point, we received one segment of the video that went through the transcoding service, and then multiple formats of this video was created in the real time in different resolutions and codecs. All of them were stored and cached, and the message was sent to the queue saying that the transcoding of this specific video segment was done. Now we have a regional delivery service, a service that listens to the job completion queue. A regional delivery service is a system or a set of microservices that must be responsible for two things. First, for pushing the video into the global edge servers. And secondly, if the video is absent in the CDN or global cache, it should be able to serve that video per request. So here on the left side, you can see we have multiple users. And As the regional delivery service receives that 1 second segment, it pushes it to the global edge cache. Global edge cache is a set of data centers or servers around the world in different localities that is responsible for mostly storage of the videos and serving those videos into the local CDNs or ISPs or to the end users. So you can think about it as that we have this regional delivery service. For instance, the game is happening in the United States. So the publishing of the video goes to the United States based data center that is responsible for transcoding. And then from the US based data center, we need to propagate those videos in the real time to the data centers in Asia, Europe, and other continents. So the video has to be transferred to the edge locations and then cached there. So from there, as the video exists in the edge locations, we can do multiple things. We can either deliver the video through the local CDNs, or we can deliver the video directly to the users from the edge cache. So over here, you can see users, they consume video in the real time from different locations. It can be either CDN or global cache. That video usually is served again in the protocols that are TCP based, like HLS or Dash, or at the same time, it can be served through the WebRTC, which is UDP based and might be not as reliable. And this process is continuous. So every single second in the real time, we receive a 1 second segment video that goes through the transcoding, and regional delivery service pushes multiple videos of different resolutions and encoding to the remote locations. So those videos can be served locally from there to the users. Now let's drill down into the specific components and talk about them in more details. So as you can see in this diagram, it all starts at the locations where the video is shot. It can be either the soccer stadium or it can be your laptop from where you stream the video. Usually if it's a big event like soccer stadium, there is a fiber optics from every single camera that you have to the production side that is also there at the stadium. For the streaming from the production side to the data center, we would likely have, again, a heavy network with dedicated links from there into the data center. In our case, let's say it can be AWS, right? So we have a side where we stream video from to AWS through the direct links. And then once AWS receives that video, this is when the process we discussed in the previous diagram starts, where we encode the video and then we push it out to the edge servers. In this case, usually the encoding of the video is done into core data centers. These are data centers that very compute heavy and large data centers. They can process and encode large amount of videos. Edge locations or edge pops, points of presence, usually smaller data centers. There are, let's say, 3-4 core data centers on the continent, and then it can be 10 or 20 or 100 edge pops or edge data centers. They're responsible for edge computing and storage of the data, just so it's closer to the end user. In our case, on this diagram, you can see that once the data is encoded, it gets sent to our edge server locations. Again, it's all done through the dedicated peering links or just transport backbone between the core data center and the edge data centers. I think on this diagram, it's more clear the difference between the core data centers and edge. So in this case, you can see we have two broadcasters on the left and two viewers on the right. So broadcasters stream data. The data first goes to the closest location. In our case, it's POP A, for instance, for the top broadcaster. POP A is a edge data center that is responsible for receiving that media and then send it to the regional core data center that is responsible for transcoding videos and all the heavy operations. And once all those heavy operations are done, then it gets sent to different POPs. In our case, if we look at the broadcaster at the top, it streamed video into POP A, and then it could go to either region 1 or region 2, for instance, for transcoding and heavy operations. And once all of that is done, that video gets delivered to multiple POP locations where it's going to be streamed from. In our case, let's say it's POP B and POP D, where the transcoded video fragments would be delivered and viewers would receive or download that video from the local POP D and POP B instead of the original POP where the video was streamed to. And as the broadcaster sends the video to POP A, that POP has to make a decision on where that video has to be sent to for transcoding and future processing. If the region 1 is busy, for instance, we want to have an ability to send it to the region 2 or region 3, so we are able to absorb a spike of traffic. So we would need some sort of intelligent proxy or mechanism in our edge POPs to be able to determine where, for instance, video has to be sent for transcoding and heavy processing. As you can see on this diagram, likely we would have let's say, broadcasters, and then we will have that media proxy that would need to make a decision on what region that video segment has to go to and assign to, which means that our edge media proxy needs to have knowledge about the state of the multiple core regions, monitor their compute and network, because it's not only compute heavy, it's also network heavy. So we want to make sure that we take all those metrics into account before assigning a region to a specific broadcast. So ideally, that information gets fed into our POP media proxy, and one knows where to send the traffic. Now let's talk a little bit about the data delivery. We spoke about multiple methods and how we can deliver video to a user. So let's look at it in more details. As you can see on this diagram, this is a more detailed view on the regional delivery service that we spoke about in the beginning. So as the video getting transcoded at the core POP and different transcoded versions of the segment stored in our cache and distributed file storage, we need to make sure that the video is delivered to as close as possible to the user. As you can see here, we have a core data center that has a regional delivery service. That service is responsible for pushing video to the edge cache servers. Usually there are specific rules based on the video demand. There is a specific manifest file to where this video has to be pushed first, because our data center supports two models. First, it pushes video to the edge cache servers, and at the same time it's able to serve videos on the pull requests. Once the video reaches the edge cache servers, there is still additional layer of cache that can be added, and this is the ISP cache. So let's say we have an edge POP in Brazil, and there are multiple ISPs that work in the Brazil. There are multiple CDN providers probably that have very good coverage in Brazil. So we would want to probably do two things. First, we might want to have a logic to push that data from our own edge cache servers to the local regional CDN providers. At the same time, we can work with the local Brazilian ISPs, peer with them directly, and put some of the servers that we have into their locations. This way, we can push the video from the edge cache to the ISP servers, and that video can be served from the ISP cache. This way, if I'm in Brazil, I have an internet connection to ISP1, that video fragment would be streamed from the ISP directly without going to the edge cache or the core system. So the latency would be very minimum. And let's say there are 100,000 users that use the same ISP in this country. So all 100,000 users can receive that video from the ISP cache and no extra computation needed. ISP would save a lot of money on the data transfer, and our video delivery system would save a lot of network bandwidth and compute resources. But let's say that I'm in the location where there is no CDN and ISP doesn't have that video cached. This way we would go through the ISP, internet service provider, and download the video from the edge cache servers. And as that segment gets downloaded from the edge cache, we would populate the ISP cache if we have any, and for the next user, we would serve it from the ISP. If the user is in the location where there are no edge cache servers, then we would go to the closest one. And if for some reason edge cache servers don't have that piece of data, we can always go all the way to the delivery service and get that video from there. And as the video gets delivered from the core location delivery service, that video would be cached all the way through either edge cache or CDN or ISP cache. This is where we would likely use LRU cache for caching the most recent content that people view. All right, and this is it for this video. I hope you found it useful. We've covered a lot of different aspects of the video streaming infrastructure, network. If you want to learn more about the system design, feel free to check out my website. I have a video course on advanced system design. If you don't like video content and would like to read more, feel free to check out my Substack. If you found this video useful, like and subscribe, and I'll see you in the next one. Bye.